Artificial intelligence like ChatGPT and Google Cloud is being used everywhere, from schools to businesses. But what most people don't know is that behind every AI system are thousands of powerful computers working nonstop and generating massive amounts of heat. This is where physics comes in. In this presentation, we'll explain how gas loss and thermodynamics helps us understand why AI servers heat up, and how this special cooling system keeps them from overheating. When we use AI programs such as chatbots, image generators, and language models, our devices work harder. And when they work harder, they produce more heat. And this heating is not just a random occurrence. It is a result of scientific principles at work.
When electrical energy power system, not all of it is converted into useful work. Some is lost as heat, and this is due to the second law of thermodynamics, which states that no machine can be 100% efficient. For example, when using an electric fan, not all electrical energy is converted into blade movement. Some is released as waste heat, warming the fan over time. This illustrates the importance of thermodynamics and gas laws in technology.
To understand this better, we should look at the ideal gas law, which describes the relationship between pressure, volume, and temperature of a gas. As temperature rises, gas molecules move faster and hit walls with even more force. Increasing pressure and volume is constant. Allowing volume to expand helps maintain stable pressure. This illustrates gas behavior under heating or cooling as seen in heat-generating devices.
Thermodynamics is the science that studies the relationship between heat, energy, and work. It occurs whenever energy changes form, such as when a laptop converts electrical energy into heat.
In our case, we'll focus on the first and second laws of thermodynamics. In the first law of thermodynamics, it states that energy cannot be created or destroyed. It can only change from one form to another. For example, electrical energy in computer turns into heat plus work. And for the second law of thermodynamics, it states there that no machine is 100% efficient. Some energy will be always lost as waste.
To test this, we did an experiment with 4 setups: idle laptop, AI work with NUC cooling, AI work with fan, and AI work with cooling fan. This will help us determine which works better for heat-generating devices.
Here are the step-by-step solutions. Step 1. Measure the CPU temperature at regular intervals. Add all the readings and divide by the number of readings to find the average. Step 2. Get the cooling efficiency by dividing the difference of the controlled setup and the experimental setup by the controlled setup, then multiply it to 100%. Step 3. Convert all recorded temperatures from Celsius to Kelvin by adding 273.15 before using them in any gas law calculations. Step 4. First determine the final pressure, then use Gay-Lussac's law to compute the percentage change in pressure for each trial and condition.
The result shows that temperature and pressure are directly related. As described by the ideal gas law, when temperature increases, pressure also rises, and when temperature decreases, pressure drops. Between the cooling methods, both the fan and the laptop cooling pad help reduce heat, but the cooling pad consistently performed better. It achieved higher cooling efficiency, around 19 to 20%, compared to the fan's minimal effect, keeping the system more stable and preventing excessive heat buildup. Overall, the cooling pad was the most effective in maintaining steady temperature and pressure, improving the setup's overall thermal performance.
Our experiments showed how different cooling methods affect CPU temperature under AI workload. When the device was left without cooling, its temperature rose to more than 60 Celsius, which means the system was working hard and producing a lot of heat. When we added the fan, the improvement was still very small and it's like there's no change in temperature. But when we use a cooling pad, the temperature drops significantly around 51 degrees Celsius. In real life, this is very similar to how big data centers and AI facilities manage heat. Just like our computer, large AI servers generate intense heat when processing huge amount of data. If this heat isn't controlled, it can damage components, slow in format, and even shut down systems. That's why companies invent inefficient cooling systems like air conditioning or small airflow type design to keep everything running smoothly.